All right, welcome to your first Everybody Remote Day. So we're on day 4. There's some problems right on the unit calendar that you'll be doing for homework. So the homework assignment was a little bit longer than probably normal, reviewing lots of stuff from last year. So for this homework, basically what we'll do is if you have questions on anything, just post them to the discussion board in the content section. And if you see someone post a question and you think you can answer it, feel free to respond to it, or I will eventually respond to it as well. And what I'll do is I'll pause on each of the homework slides for a second. I'll first have just the solutions, and then there'll be worked out solutions eventually, and I'll pause on each of those for a couple of seconds so you can pause the video and check your work, and then hit play again to keep the video going. So these are all the worked out solutions now. All right, so we're going to be going through a whole bunch of problems that review things from last year. And these are not in your notes packet, so you can just follow along with the video. So we want to know which graph has the following properties. So g of x is less than 0. So that means that we know the y's are negative. G prime is greater than 0. Well, your derivative tells us increase, decrease. If it's greater than 0, that means we're increasing for all x's. And the second derivative is less than 0. Second derivative tells us concavity. So this means we are concave down. So we're looking for a function that is always concave down, is always increasing, and always has negative y's, and the one that meets those criteria is choice D. Whenever you're given a graph, always be sure to look closely what type of graph is given. So our original graph here, they tell us is an f prime, and these are possibilities for f. So the y values in f prime tell us about the slope in f. So we go negative y values to positive y values to negative y values. So we're looking for something whose slope goes negative to positive to negative. And there's only one of those that matches with that, would be choice B. Give you a moment to read through all of that. All right, we got continuous on a closed interval, differentiable on an open interval, and we've got the y values of our endpoints are equal to each other. They're both equal to 5. Those three things together, hopefully one of your theorems clicks in your head. That would be Rolle's theorem. And Rolle's theorem guarantees that somewhere in between the endpoints, there should be a value of x where the slope of the tangent line is equal to 0, where the derivative is equal to 0. So those three things together give us Rolle's theorem, which is telling us choice 2. Now, we only need to be continuous on a closed interval for another theorem that we have, the extreme value theorem. The extreme value theorem says if you have a closed interval with a continuous function on that closed interval, that you're guaranteed to take on a largest and a smallest value. So that's what 3 is saying here. There's some value of x that is greater than or equal to all other values of x in the interval. So that's our absolute maximum for that extreme value theorem. Now 1 is saying that you have to have a y value of 0. There's nothing, we don't have any theorems saying that we have to have a y value of 0. Something that could maybe lead you to that is, say they told you f of -2 is a negative number, and f of positive 1 was a positive number, then by the intermediate value theorem you would know there's got to be a value that equals 0 for the y's. But we didn't know that, so we could not conclude that in this case. So we would have choice D. Now, as we're doing these, if you'd like, you can pause the video right when we flip to the question and try it on your own, and then you can hit play to see if you did it correctly if you want to try and challenge yourself. If you don't feel comfortable with the topic, feel free to just play the video through, but if you'd like to give it a try on your own, that's something that you can be doing as we're doing this. So we like our x's to come first, and we like them to be positive when we're factoring these. And I'm going to go ahead and pull the negative out right away. So this will be minus and then x squared minus 9. So this is minus, and then we've got our difference of two perfect squares. Got x minus 3 and x plus 2. The x minus 3's can divide out. Now remember, graphically what that would mean is that x minus 3, x equals 3, there would be a hole in the graph. So that limit is equal to the limit as x approaches 3 minus the quantity x plus 3 over x plus 2. And this is now something we can do with direct substitution. This will end up giving us minus 6 over 5. So another one of our theorems, the mean value theorem. So mean value theorem says that it needs to be continuous on the closed interval. X cubed is continuous everywhere. It's got to be differentiable on the open interval. Differentiable means there's no corner points, kinks, discontinuities, and x cubed is good with that. It's a nice smooth curve. Well, then we're guaranteed that the slope between the endpoints should equal the instantaneous rate of change somewhere. So let's find what our endpoints are. If we sub in 0 to x cubed, we get 0. Sub in 4, we get 64. So I have 64 minus 0 over 4 minus 0, which will give us 16. Well, then we need our derivative, our dy over dx. That's going to be 3x squared. So we know that 16 must equal 3x squared at some point. The slope between the endpoints should equal the slope of the tangent line, which is the same as saying the derivative. If we divide by 3 and take our square root, so we would get plus and minus 4 over radical 3, or rationalized, that would be 4 radical 3 over 3. Now, We can get rid of the negative because it's not on the interval. And so you could either give that as an answer or to 3 decimal places, 2.309. Remember the AP rounding standard is to 3 decimal places. All right, so we're dealing with rates here. This is a related rates problem. Circumference of a circle increasing at pi feet per minute. Find the rate of change at the area when the radius is 6 feet per minute. So we're going to need two formulas. We've got our circumference is equal to 2 pi r, and we're going to need to work with our area formula as well. So we're going to take our derivative with respect to time. If anything's constant, any of the quantities are constant, the entire scenario, you can put them in before the derivative. We don't have that in this case. So we're going to have dc over dt is equal to 2 pi times dr over dt. They told us that dc over dt is increasing at pi feet per minute. If it was decreasing, you would put it in as a negative. That equals 2 pi dr over dt. And if we divide the 2 pi over, they'll be in the denominator. So we'll get a half equals dr over dt. And our units for that would be feet per minute, because radius is a one-dimensional measurement. So if we go ahead and take our derivative here with respect to time, we've got dA over dt equals 2 pi r times dr over dt. I think it's sometimes helpful to identify what we are trying to find. We want to find the rate of change in the area, meaning we should be able to sub everything else in. So we got dA over dt equals 2 pi. We've got 6 as the instant for our radius, and we have a half as our d over r over dt from the previous one. So this is just going to give us 6 pi, and it's a rate for an area, so it's feet squared per minute. All right, last one in this video. So we want it to be differentiable at x equals 3. You can't be differentiable if you're not continuous. So one thing we know first is it has to be continuous at x equals 3. Well, if we sub in 3 to the top part of the piecewise function, we get 9q. If we sub 3 into the bottom part of the piecewise function, we're subbing in for x, I should specify, it's 18 plus p. Well, that's an equation with two variables, so we need something else. Well, if it's going to be differentiable, that means we need the derivative to be continuous. So this would be 2xq when x is less than 3, and we would just have 6 when x is greater than or equal to 3. So by subbing in 3 for x, we'll then set those equal. Dividing by 6, we get q equals 1. So that's half of our answer. And then putting the q equals 1 in over here, subtract the 18 over, and we get negative 9 is your B. Okay, so if you want it to be differentiable, it's got to be both continuous and differentiable, because it can't be differentiable if you're not continuous. All right, other ways to be studying for the test later in the unit. The first test is to review that whole summer packet. That basically is your review sheet. Normally you would get a review sheet for exam, but the first one, that summer packet, is the review sheet. And just a reminder, our homework for tonight, we've got the problems that are on the unit calendar. So take a picture of those and upload them to Schoology.